We're here at VMworld 2010, where the theme is Virtual Roads, Actual Clouds. We're here to talk about a very unique challenge that's Carnegie Mellon University and a partnership of HP, VMware, Samsung, and Intel met to stand up a private cloud in less than 30 days. Greg, tell us something about the project and why it's important to CMU.
So Carnegie Mellon University is one of the top research universities in computer science in the world, and we have a large amount of computing needs for our education and research activities. And today, most of those are handled by distinct infrastructures whose utilization is far lower than we'd like, and the expense of doing that is far higher than we'd like. And we went around the university and got a bunch of people on board with moving towards a cloud model, and once we did that, we really wanted to move quickly on getting the cloud in place. University folks have short attention spans, and if you linger too long, they'll change their mind and do something else. And so going quick was important to us. And HP and VMware, Intel and Samsung got together and were able to do that for us in actually quite a bit less than 30 days.
Jim, tell me something about HP's motivation for becoming involved in this project and what we were able to do with our partnership to be successful in standing up this cloud in less than 30 days.
So from HP's perspective, we all know that cloud is a huge trend and it's accelerating. We want to make cloud compelling. And the way we're going to do that is one of our latest and greatest offerings, which happens to be our Cloud Start. By working with really great partners such as Carnegie Mellon and others, what we were able to do is not only go in and do a full-fledged assessment of their needs, literally from the infrastructure all the way to deployment, but equally as important, be able to stand that up in less than 30 days. And the reason why we can do that is because it's based on our converged infrastructure. Converged infrastructure, in our perspective, is the blueprint for the way that all future data centers should be designed and delivered. Simple, integrated, automated, and what that allows us to do is very similar to what CMU is now deployed, not only put in infrastructure for future research and database analysis, but more importantly, give us an observatory or a real-world laboratory that we can see how our clouds being designed, delivered, and what future things we want to go put into them.
Jim, tell us about Samsung's involvement and how green DDR memory is really important to the operation of a private cloud.
Sure, so if you think of DRAM as the building blocks of an energy efficient server, the new 35 nanometer DRAM we have today is about more than 80% efficient than the generation we had just a few years ago. If you look at that at the system level, it's about more than a 40% reduction in total power consumption. And one proxy to look at is if you were to take all the install base of servers in the world and switch them over to the latest green DDR3 technology from Samsung, you'd save about $2 billion a year in energy costs.
Jake, in this project we use Intel processors. Please talk to us about the importance of the latest generation of Intel processors and how they impact the operational efficiency of a private cloud.
Well, I think it's very important for us to be honored to have the opportunity to participate with Samsung and HP and Carnegie Mellon and continue our research efforts. But the contributions of our microprocessors enable the research teams and the university to begin to build a virtual and cloud infrastructure with capabilities to provide security for today and do the research to provide security solutions for tomorrow. And we think it's important to put in the hands of some of the smartest young men and women on the planet the next technologies that they can develop solutions so that we can move forward in this industry and deliver the next set of solutions for cloud technology.
I'd like to turn to you, Greg, one last time and ask you to sum this up. What's next?
Well, so we've got a first version of the cloud in place really quickly, and we're already using it for our real work. But now we want to build it up bigger, right? The great thing about cloud is you can start with a size that makes sense on day one, and you can add to it. It's supposed to be seamless to do that. We're going to test that. What's next is we're going to make it a lot bigger to handle more of the university activities.